Hello, and we're back. We're looking at systems of equations, and this time we're going to solve by elimination. Now, you'll notice that we have two equations and two unknowns, so we should be able to solve for this. Okay, so we have two equations in standard form, two linear equations in standard form. The thing with this idea is that we add the equations themselves to get rid of one of the variables. And this one's a nice, easy one. If you'll notice, if we just add the columns here, 3y plus 5y is 8y. 2x minus 2x is 0x, or 0. And that's why we're doing this, to get rid of those x's. And then 6 plus 10 is 16. So if we solve for y, you can see that we find y is 2. The way to find x is to plug that back in and solve for the other variable in either equation. It doesn't actually matter which one. I'm going to use the first one, but again, it doesn't matter which one it would be. So if I take y equals 2 and plug it back in right there, then you can see that we have 3 times 2 plus 2x, equals 6. Let's fix that. 2x equals 6. 6 plus 2x is 6. So x is 0. So the solution to this is 0, 2. And we can check our work. This point should be a point that solves either one of these equations. Okay? So if I plug that back in, 3 times 2 plus 2 times 0 equals 6. That works. And 5 times 2 minus 2 times 0 equals 10. And that works, okay? You'll notice that I plugged in the solution here into the first one, and if I plug in the solution into the second one, it also works. And so both equations are true when I plug in the solution, all right? Now, of course, this was easy because 2x minus 2x is 0. Usually that doesn't happen, that it's nice and easy. So for example, if I added the columns here, it wouldn't work out, right? Because 3x plus 5x is 8x, y plus 4y is 5y. That doesn't work out. But you'll notice I can, if I wanted to cancel out a variable, the easiest thing would be to multiply the first equation by -4, because then I'd be able to cancel out the y's. Okay, so if I do that, I have -12x minus 4y equals -36. Now this is the same equation as the first one. I've just multiplied it by a factor of -4. So now I can use the elimination method to eliminate the y's, right? So if I add the columns, I get -7x equals -14. Then y's now cancel out, which is what I wanted, and I figure out that x is 2. And again, I plug that back in to either equation. I can do either one, but I'm going to plug it into the first equation. Okay, so if I plug this back in to the first equation right there, right? So we have 6 plus y equals 9. Y is 3. So the answer is 2, 3. And again, I can plug this back in to double check that this works in both equations. But it will. When you plug this back in, the first equation to the second equation, it will be true. So that is the elimination method. And this is a representation of where these two lines intersect. Okay, I hope you learned a thing or two, and we will see you next time.